In this video, we'll be talking about using the calculated load information in Revit and how that can help you streamline your production process. We've kind of left out the middle segment of this previous video and this one in regards to running the load calculations and whether you do that within Revit or if you do that in third party. We'll be adding a video down the road to highlight one of those workflows to show that. So right now we've, in this particular sample project, we've exported the GBXML information. We've calculated the loads in train trace. We've exported that from train trace, and now we've imported back into Revit. So we're right at a point now where our spaces have calculated information. So selecting a space, you can see that we have a calculated supply airflow. We also have calculated heating and cooling loads. So now this is the type of information that helps us get our construction documents done. So there's lots of ways to balance out air terminals, and we're going to show you two methods in this video, and then we're going to talk about an awesome method down the road using Dynamo to entirely automate this process. But at the moment, let's look at this in plan view. So I have a working ceiling plan open. Sometimes I like to do my HVAC modeling under working here, ceiling plans, and this HVAC ceiling plan. So you see where the lights are, you see the ceiling, you can host elements to the ceiling, and you can work on your ductwork all at the same time and place. First thing is we can use our tags to show us what the airflows are in a given space. So if I select all instances of these tags, and then we change these tags to show, so this room name and number comes from project setup. If you watch that video, we'll change to space name and number and airflow. All right, there we go. So now we have a tag showing us for the space what's our calculated airflow and what's the actual airflow. So whether you have ductwork connected or modeled at this point, it doesn't matter. You just need the air terminals placed, and then you get the airflows assigned, and then once you start making your connections, then that information will feed into the VAV boxes, which will then auto size and everything else downstream. So this is a pretty simple room to balance. I'm just going to select the two diffusers that I have, and we're going to give it 200 CFM. All right, first room done. Let's go to this next room here. So we've got 191 calculated CFM. I'm going to select these two diffusers and give them 100 CFM. So instead of going back and forth with PDFs and looking at load calc sheets, this just has all the information right in front of you and the designer to make this happen real fast. Now let's say this is a very, very big project, and you maybe didn't want to go through all the plans to do this. I already have tags on the diffusers, which makes it even easier. So we've set up a schedule to make the process even easier. So if you go down to M_design, so these design schedules we've talked a lot about now in the user manual. So you guys should really get familiar with these. There's a whole bunch of useful tools here to help you with your designs. But let's look at this airflow in spaces. So this is essentially a space schedule, as the group shows up here, with an embedded air terminal schedule. So these descriptions down here are the embedded schedule from air terminals. And how that's set up is if you go into fields, well, starting on fields. So not every schedule you can embed schedules, but space schedules you can. They have an embedded schedule tab, and then you can choose what type of schedule you want to embed. And then essentially now we're building an air terminal schedule. So what this does is this will show the air terminals that are found in a given space. We have our actual and calculated air supply airflows and then the percent difference. We have return and exhaust, and we're also doing a pressure check as well. So, you can just scroll down here and look at the spaces that we haven't balanced yet by looking at this difference from actual to calculated. So I think I set this to turn red if it's greater than 5%. So, you can adjust that as you would want. But, this room here, okay, sure. Let's change this to 85 CFM. So that was in the men's restroom, actually where the heroes go to the restroom. That looks good. So now we're not so concerned with plans or where a diffuser is exactly located. We have all the spaces in a model, and you could balance a building very fast. So now we've got 2 3-cone diffusers here. We're going to give these an airflow. So the gray values right here are what the space is showing for actual airflow, and then the values below that are the actual diffuser airflows. So these are the diffusers, this is what the space shows, and this is the calculated values, so that's good to go. Let's balance this one. And you'll see we also have the next size, so for any diffuser family that has auto size functionality, you'll see that update in this schedule just the same. Here's Castle Grayskull. So let's give these some airflows, 100. And 100 CFM. So I think you guys get the idea. I mean, you could do a very, very large project and you could balance the entire building without clicking on a single tag at that point in time. And then when you go to your plans, you're just tagging the information and it's already filled in. So we're not going to go much further in this video here. However, there is very, very cool things to come. It's no secret there's been lots of presentations on using Dynamo to automate this exact process, and we plan on including a Dynamo script to do that. So we're gonna, I consider it a magic button, but that is truly going to show you why you're going to want to get your calculated loads into Revit, because you're going to be able to run a script, assign all of these calculated airflows to all of the placed air terminals just like that, and you'll be done. Talk about a very large project. I can't even quantify how much time you're going to be saving. Hope you guys enjoy.